Well, good morning. These are the notes for 8.1. We're starting chapter 8 today. I wanted to mention that our calendar is pretty well shot from all the snow days. So I know this says 8.1 on Monday, but yeah, no, we're doing that today. What about 8.2 and the rest of it? It's kind of going to depend on what's happening with the snow days. So try not to stress too much. We'll keep you guys updated what's happening all of the time, but we're gonna do 8.1 today. All right. Oh, what is today? Today is we're starting March. Very cool. Okay, you might notice there's all this stuff in the bottom here. That's because this unit doesn't have a test; it has a project instead. And so these pictures are kind of examples of what you guys will be making drawings of. So more to come about that. Okay, so section 8.1, we're going to be looking, this chapter focuses on area, and we're going to be working on the area of triangles and circles. Now, you guys in middle school and in elementary school have probably done some stuff with area with these shapes. However, COVID, I know, did put a big kind of dent on things. And so we want to make sure and not make assumptions about what you may or may not know. So we're going to try to do a really good review here for you. But the goal is for you to be able to find the area of a circle and the area of a triangle after today. When we're talking about the area formulas, we need to have some vocabulary in place. The first one is the height of a triangle. The height of a triangle forms a right angle with one of the sides of the triangle. Now, this can look a lot of different ways. It might actually be a side of a triangle, but it might not be. Let's take a look at some of these. In order to find the height of a triangle, we need one side that we can identify as the base, and we need a right angle drawn to that base. The other side, or the other part of that right angle, is the height. If it's a right triangle, then the legs are the height and the base. However, take a look at the second triangle. If the base is this side, we're looking for where's a perpendicular drawn, a right angle drawn to that base. Here's our right angle. And the height is actually not one of the three sides of our triangle, but it's the other part of the right angle where the base draws part of that right angle and the height draws the other part. If we have a situation where we have an obtuse triangle and we're trying to use one of the sides that forms the obtuse angle as the base. Here's my base. The base would stop right here. And there is no right angle that could be formed inside this triangle. This is the most unusual type. In order to form a right angle, we'd actually have to go outside the triangle. And then the height, again, is not one of the sides of the triangle. I think most commonly you're going to see the first two examples, but we will expose you to all three just to make sure you know how to handle it. The base of the triangle is going to be one of the sides, and you could actually pick any of the three sides of the triangle to be the base, but then the height must be perpendicular to that base. The formula for the area of a triangle is 1/2 base times height. It's commonly written like this: B is the base, H is the height. These are all being multiplied together because we don't have any space in between these little portions here. Now, some people write it like this instead: base times height divided by 2. Multiplying by half and dividing by 2 are the same. So if you'd rather write it like that, that's up to you, whatever you prefer. You might be wondering where this comes from. Well, I'm going to look at a shape that we're a little bit more familiar with, a rectangle. And the area of a rectangle, you're probably aware, could be found by length times width, or we could call that base times height. Well, if I draw in a diagonal, and a diagonal is when you connect two of the sides that are not right next to each other like this, you might notice that I've now taken this rectangle and I've split it up into two triangles. These two triangles are the same. They are congruent to each other by side angle side because of the opposite sides of the triangle, of the rectangle, being the same in the right angle. But so what ends up happening is the area of the triangle is half of the area of the rectangle. And since the area of the rectangle is base times height, it's 1/2 of base times height. And that's where our formula is coming from. Okay, so in these next three examples, we're just going to be finding the area of each triangle, and then there's a couple for you to try. We'll have you pause the video at that point. I'm going to recommend, you're going to have a ton of formulas as we go through this unit. I'm going to recommend that you write down the formulas as you start the problem. This would allow you to memorize the formula and it'll help you solve the problem. We're finding the area, so I'm going to leave A as my unknown. The base is one of the sides of the triangle, that would be the 18. The height is the perpendicular, and height does not have to be one of the sides of the triangle. You can do this mathematically a lot of different ways. You can do 1/2 of 18 is 9 and do 9 times 6 to get 54. That's fine. I think more commonly what people do is they multiply these two together first and they get, let's see, I guess that's 108, and then divide that by 2. You can also just do all of this in the calculator once. So I'm going to pull up my calculator to show you. So 1/2 is the same as 0.5. So I could do 1/2 or 0.5 times 18 times 6. I could also do 18 times 6 and divide it by 2. That's another way to say 1/2. Notice each way we're going to get the 54 that we're looking for. I don't need to see your computation in your answer, so you can go straight to 54. Now what area does? Area tells us, I'm going to go back to our rectangle, how many squares are inside a shape. How many squares are inside a shape? That's why often when you hear people talk about area, area is going to be measured in how many squares we have, which is area is measured, oh my gosh, I need my coffee, in units squared. So sometimes they're going to tell you like, oh, these are millimeters or feet or centimeters. If they don't tell you units, take a look at number 1. 18 and 6 don't have a unit of measurement with it. We just usually write units squared like that. Now every teacher is a little bit different. This is Mrs. Ault doing this video. I am going to require that you put units squared or inches squared or wherever it might be. Let's take a look at the next one. So the formula for area again is 1/2 of base times height. Base must be one of the sides. Area is what we're finding. I'm going to leave that as A. Base should be one of the side lengths. I'll pick the 6. It doesn't matter. The height is the other part of the right angle that's formed in order to get the right angle. So the height here could be 7. By the way, we could have called the base 7 and the height 6. It doesn't actually matter when you're multiplying. And then from here, we could use our calculator if we wanted, or we could do 1/2 of 6 is 3. 3 times 7 is 21. We could also do 6 times 7 is 42, and then cut that in half to get 21. And then this would be in inches squared. Again, if you'd like to just see that on the calculator, one easy way to do that is to do 0.5 for the 1/2 and then times 6 times 7. We could also do 6 times 7 and then divide that all by 2. Either way, we're going to get the correct answer. Number 6 on this one, same formula. Area is 1/2 of base times height. And then area is what I want to find, so I'm going to leave A blank. Now the base needs to be one of the sides. Anything dotted is not actually in the triangle. So this is the base right here. The only side I know of the triangle is 14. So 14 must be the base. The height is where the right angle is drawn with that. And it's kind of funny because it's outside the triangle here a little bit, but the height is going to be the 10. And now I will compute this. I could either do 14 times 10 is 140 and then divide that by 2, or I could do 1/2 of 14 is 7. 7 times 10 is 70. And then my units are meters squared. Totally okay to use your calculator on your phone or whatever you'd like. Desmos is a great one. Okay, I'm going to pause the video. And I'm going to write up the solutions for this. Please pause the video as well. Try these 3 problems, and then when you're ready, you can compare. All right, well, welcome back. I've got my solutions up here for you if you want to take a look at them. I do want to mention a couple things as well. First thing I want to mention is that you might notice that I have units squared listed for every single problem. You might want to look at that as well. Make sure that you have that. So don't just check 20, 24, and 12. Check those units, make sure you've used the correct ones. Something else I'd like to mention is that when we grade these on the tests, it will be important that I can be able to tell what numbers you're multiplied. This part here is going to be really, really crucial. You will get points for showing me what you're multiplying. If all I get is an answer, you will not get the full credit on a test or on a quiz. Typically, there's 3 points for the setup and 1 point for the answer, and maybe 1 point for the units. I haven't decided yet. But if this is only 4 points and you skip all of this, you don't have all of this, you've now earned only 1 out of the 4 points, which would be super, super sad. You really want to make sure that you're getting all of the points. And so process is important. I'm trying to not just see, can you get the right answer, but can you communicate mathematically, and are you using the right process? Because maybe you got the 20 for another reason by accident. I don't know that. And so I want to be able to measure your understanding. So I need to see the numbers. Now, what about the formulas? Is writing the formulas required? I'm going to recommend it. I'm putting it here in green. This is optional, but you're going to have so many formulas to pick from that you might find it helpful to, at least for now, be writing that formula. And perhaps as time goes on, you won't need to. But I'm not going to mark anyone down for not writing the formula. However, if you do write the formula, then I can give you a point for that, even if you kind of mess up in plugging in the points. So kind of what will happen is this whole part is worth 3 points. You can get all 3 of them right here, or you can get 1 of them here and the other 2 here from plugging in the 8 and the 5. So the green part, again, is optional, but you might find you're more successful with writing it. I'll let you decide. All right, let's go on to the next page. Sometimes they're not going to tell you everything. Sometimes you might not know the height, you might not know the base, or they might give you extra information that you don't use. So it's possible that you're going to have extra numbers in the problem that you don't use. But there are some things that you might find helpful. The Pythagorean theorem, a triple, or a special triangle might be helpful. So a couple things. Pythagorean theorem, remember, is a squared plus b squared equals c squared. We can use that with any right triangle only. Our triples, we have 3, 4, 5. 5, 12, 13, 7, 24, 25, and 8, 15, 17 as the ones we're using. There are an infinite number of triples, so there's more than this, but these are the ones we're asking you to be able to recognize and use. Or special triangles. Those are our 30, 60, 90, and 45, 45, 90 triangles. So maybe I'll draw 45, 45, 90 first. You might just find it's helpful to have this here. 45, 45, 90, remember, is isosceles, and it's in the pattern of 1, 1, root 2. We might see the 45-degree angle written in. You might not. You might just see the isosceles right triangle. A 30, 60, 90 has the pattern where across from the 30, opposite the 30 is 1. Opposite the 60 is root 3, and the hypotenuse is 2. So we could use any of those things. To be honest, we could even use SOHCAHTOA and use right triangle trig if we didn't have some of these familiar pieces. All right, so let's take a look at 7. We're still finding the area of a triangle. So we're still going to be using area as 1/2 base times height for all of these. Oh my gosh, my pen changed color halfway through. The key is what is the base and what is the height. Look for the right angle to help determine that. Okay, the side length here, the 2 lengths that form that right angle, those are your base and your height. So this area is 1/2 of 15 by 9. Now, you're not always going to get a whole number answer here. If I multiply this out, I'll do 1/2 of 15 times 9. I'm going to get 67.5. That doesn't mean you did it incorrectly. It just means we didn't get a whole number. What this tells me is that as I drew in, like, this is supposed to tell me how many squares are inside this figure. Okay. If I draw, 15 squares this way and 9 this way. So there should be 67.5 squares. That's what the 0.5 means. It just means that because of the shape of this triangle, we couldn't fit in a full square. Now, we always do need units. If units aren't mentioned, I'll use units squared. All right, for the next one. Again, I'm trying to use areas 1/2 of base times height. But I have a base. This is the base right here. What I don't have is the height, and I need that. So I'm going to use the ratios of 30, 60, 90 triangles. Opposite the 30 is 1. Opposite the 60 is √3, and the hypotenuse is 2. If we take a look at this, you might notice that this triangle has been dilated. Oops, sorry. I thought I was highlighting. Try again. There we go. Yes. Okay, this triangle's been highlighted or dilated by a scale factor of 12. So each of the sides are actually 12 times bigger than my ratio of 1√32. So I don't actually care about the hypotenuse. The hypotenuse is 24, but I don't need it. It's not going to be part of my area formula. But the height I need. And so the height is 12√3. And now I can go back to my area formula. This would be 1/2 of the base times the height. You might wonder, how do I handle the √3? The directions tell us to simplify radical answers. Another way that this could be kind of interpreted is that we don't want decimal answers. And this is so funny. My pen is like magically changing. So how are we going to handle that? Well, when we're multiplying by a √3, what this tells us is there's going to be a √3 in the answer. So I'm going to multiply the rest of this. I'm going to go 1/2 times 12 and then times another 12. So 1/2 of 12 is 6. 6 times 12, if I'm doing my math well today, is 72. I'll just double check that, show you how I'm going to enter this into the calculator. You're going to see I'm not going to put in the √3. So I'm going to do 0.5 times 12 and times 12. This is going to give me the 72. The √3 is part of the answer, but I didn't enter it into the calculator because the calculator will give me a decimal equivalent of that. There are no units in this problem, so I'll write this as units squared. Number 9. So I've got a couple side lengths here. The question is, are they the base and the height? Are they the ones that I need? They're not. Well, one of them is actually. I need to look and zoom in on this right angle. These are the side lengths I need. The ones that form the right angle. The 5 is the base. And this missing side length over here is going to be my height. Well, you might recognize this as a triple. This is 5, 12, 13. And so I can use 1/2 of 5 by 12 in order to get my answer. 5 times 12 is 60, and half of that is 30, or I could, of course, use my calculator. I could also do 1/2 of 5, which is 2.5 times 12. A little harder for me to multiply that, but it still works. All right, last one on this page, or on this part. So again, I'm finding the area of a triangle. And I want to really pay attention to where the right angle is because that's going to identify the base and the height. So the base here is this 18. The height I need to find. In a 45, 45, 90 triangle, the ratio is 1, 1, √2. So this is isosceles. So if one of the legs is 18, so is the other. So my area could be found by doing 1/2 of 18 by 18. You might feel like you want to use a calculator on that. Those numbers are a little bit larger. That's totally fine. Just as a reminder, so you can remember your options, I could multiply the 18 and the 18 first, and then handle the 1/2 by dividing by 2. Notice I'm dividing by 2. I'm not dividing by 0.5. That is important. Okay, I'm dividing by 2, or I can multiply by 0.5. You don't want to get those mixed up. Those are different things. Okay. So this next part, these are ones for you to try. So I'm going to pause the video, and you should pause it as well. When you're ready, restart it, and I will do the same so that we can check the answers for these. All right, welcome back. I've got my solutions up on the screen, so you could pause them and kind of compare with your own. A couple things. Notice I've got units squared for each one of these answers. That's because they didn't give me specific units, but I still want to recognize this is telling me how many squares could fit inside these triangles. If I go 8 squares across, and 6 squares up and down, I would fit 24 squares perfectly inside that first triangle. The 8 and the 6 are what I chose because that's where the right angle is. I had to find the 8. I used a 3, 4, 5 triple. The Pythagorean theorem could also be used. For number 12, the right angle would require me to use the 2 legs. One of the legs was already given as 8. The other is 8 root 3 after I use my ratios with my 30, 60, 90 triangles. Notice how my answer has the radical still in it. So what I did to simplify this is I did 0.5 times 8 times 8, and that gave me this 32. And then I made sure to multiply by the root 3 at the end. For number 13, the thing that was kind of tricky about this is that they gave us extra information. We really only care about the side and the height that have the right angle between them. So those other sides were distractors, just to make sure you were selecting the right numbers and not just automatically picking the numbers that were there. So that was the purpose of that. So we're going to only use the 12 and the 4 because that's where the right angle is. So that would be our base and our height. All right, let's move on to number 14. A triangle, so we're still working with triangles here, has an area of 40 inches squared. The height is 10, and we want to find the length of the base. Since we have been mentioned the area of a triangle, I'm going to start with that formula. And then they gave me some information. This time they gave me area. That is A. I'm going to replace or substitute in A with 40, or plug in, if you will. And then what they want me to find is the base. I'm going to leave base as the letter B, and the height is 10. I'm going to solve this. Now, I'm going to recommend that right here we go ahead, and multiplication can be done in any order. So I'm going to just kind of reorder this. I'm going to do 1/2 of 10. So 1/2 times 10, or 0.5 times 10, or 10 divided by 2. You can think of it any of those ways. Would simplify to a 5, and that's still multiplying B. And then I'll use the little algebra here. And B is 8, so my answer is D. Now, some students would do this differently. Some students would maybe test the different answers, multiply these by the height 10 and divide by 2 and see which one gives you 40. There's nothing wrong with that. If you prefer that method, if you wanted to test maybe part D, you could do 1/2 of 8 by 10 and just verify that it gives you 40. That works awesome if it's multiple choice. However, if a problem is not multiple choice, then you're going to need another strategy, which is why I used this one. Not everything is multiple choice. All right, let's move on to circles. So when we're looking at circles, we do need to, again, have some vocabulary. The radius of a circle is going to connect the center of the circle to one of the points on the circle. Here's a radius right here. Now, it could be anywhere around the circle. The radius will be the same all the way around the circle. That's why we get this beautiful symmetry in a circle. A diameter, instead of going halfway through the circle, will go all the way through. It'll still pass through the center, but let's see. The diameter of a circle is a segment passing through the, oh my gosh. And we have it twice. Passing through the center, and then it has the endpoints on the circle. This really was just a little repeat of what we were putting in the blank. There we go. Now, the relationship between the diameter and the radius is that the diameter is twice a radius. A radius is only going halfway through the circle. The diameter is going fully through the circle. So there's a nice relationship there. To find the area of a circle, area of a circle is found by pi times the radius squared. Now, pi is basically this awesome number. I'll show you guys a video of it on Pi Day. When you were in middle school, you probably used it as 3.14. And then maybe you've seen in my classroom that we have some extra 3.14159, da 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 da. In fact, if I go on my calculator and I type pi, you might think, oh, pi has about 10 or 12 decimals. Pi is irrational. It actually keeps going on forever. And because we want the most accurate answers we can get, we are not going to use 3.14. We're going to use the pi button on our calculator if they want it as a decimal. Okay, there is a pi button on the calculator. By the way, the way pi is spelled, it's a Greek letter. It's kind of like how we use X or something. It's spelled like that, pi. And so there, it actually has its own button on the calculator. R in this formula is the radius. So sorry, I didn't mean that to happen. There we go. And we do need to square the radius in order to do this. All right, let's try a few. Now, you're going to see some or some different forms of answers that are requested. Sometimes we're going to write our answer in terms of pi, and sometimes we're going to want a decimal. And I'll show you what that means. All right, for the first one, I'm going to recommend we start by writing out the formula. Area is pi r squared. Area is what I want to find, so I'm going to keep that as A. Pi is a number that is more convenient to write with the symbol pi than the 3.14159 because it's irrational. We can't write it accurately. The radius in this circle is 9, and I'm going to need to square it. Now, what does it mean when we say in terms of pi? If it says in terms of pi, what that means is we want to take this pi and tack it onto the end of the numerical part that we would get from squaring this. 9 squared is 81. This is my in terms of pi answer. Notice I didn't actually write pi as like 3.14159. I just kind of kept it there as its own special number. I still do want units at the end, so I'll write inches squared at the end. Let's take a look at the next one. Area would be pi times the radius squared. So that'd be pi times the 3.5 squared. Well, this has different directions. They want me to round this to one decimal. I'm not going to use 3.14 for pi. I'm going to use the pi button. Your phone calculator, Desmos, our classroom calculators, these all have a pi button on them. So I'm going to actually type it just how it looks. I'm going to do pi and then times 3.5 squared, or you could do times 3.5 times itself. But I think the squared button is pretty handy. We'll get around 38.48, but since we're rounding this to one decimal, this second decimal informs me to round the 4 up to a 5. So this would be, oh, I already forgot the answer. Was it 38.5? Now there are no units on this one, so I'll put units squared. Last one, area is pi r squared. And so the radius, I want to be careful here. The radius is only halfway through the circle. So if the diameter is 24, if I cut that in half, the radius is 12. That's what I want to square. This direction says to write my answer in terms of pi. So when I write my answer, I'm going to keep pi. I usually write it after the number is the common way to write it. And then I'll do 12 squared, which is 144. Last is any units. All right, you've got a couple here to try, number 18 and 19. So I'll pause the video and let's have you pause it as well. Let's check in momentarily. All right, so go ahead and compare your answers. Notice how 18 asked for this to be rounded to a decimal and 19 did not. I think in terms of pi is actually the easiest way. Just don't leave this off of your answer. It is a part of your answer, so be careful there. I do want to just mention again, how do you find the pi button on the calculator? Every calculator is a little different, so you'll have to look. On mine here, it's blue. I think on the scientific ones we have in our class, it has its own button. But so if you want something, remember that's kind of above something, you might have to hit the shift or second button. Your phone calculator should have a pi button on it, which is pretty nice. Okay, we have one last one. A circle has an area of 36 pi centimeters squared. We want to find the radius and the diameter. Well, I'm going to start with the formula for area. And they told me the area. So this 36 pi, I'm going to go ahead and plug in on this side. And I want to solve this for the radius. Well, you might remember that in algebra, if you have the same thing on both the left and the right side, that they balance each other out and you can cancel them out. So I'm going to cancel out the pi's, and I'll get 36 is r squared. And now I have an equation I want to solve. When I solve this, the radius is going to be 6. Now, technically, when we square root both sides, we get plus or minus, but we don't use negative lengths. So I'm just going to say 6. Now, the units. If the units for the area are centimeters squared, then the radius would just be in centimeters. The radius doesn't tell us how many squares we have. It just tells us how long it is. The diameter is always twice the radius. 6 times 2 would make that 12 centimeters. And that is the end of our video for today.